session. Good morning, all. My session is like I'll be discussing about how we can unlock the potential of metaverse using cloud computing, or how cloud computing is a boon for metaverse bandwagon. So, let's start with the presentation part. Let me share my screen first. So, I hope my screen is visible to all and I am audible. Right, sir?
Yes, ma'am.
Yes, ma'am.
Okay.
It's
So, we can
audible
start with the
and visible.
presentation part. So precisely, I'll be covering the overview of cloud computing, various service models of cloud, various deployment models of cloud, then how cloud promotes the adoption of metaverse, and then I'll be taking a case study pertaining to Microsoft Azure. So, as you all know, till now you have undergone various sessions on metaverse. So, metaverse is a combination of two terms, meta and verse, where meta means beyond and verse refers to universe. So, that means this is a world beyond the universe, beyond the physical world, right? So we can say metaverse is an imaginary world that has no physical existence. So it's a kind of a virtual world where billions of people are going to live, work, shop, learn, and interact with each other. That's from the comfort of their homes in the physical world. So this kind of 3D virtual space is going to utilize various technologies, that is virtual reality, augmented reality, artificial intelligence, internet of things, cloud computing, and blockchain. So the focus in this session will be on cloud computing. So as you know, to support the virtual world, the mammoth size of workloads of metaverse, we require a robust and scalable infrastructure. Why scalable? Because in the time to come, the number of users are going to grow, and to provide them an immersive and seamless experience will be requiring this kind of infrastructure, will be requiring massive amount of computing and storage infrastructure, that too should be scalable. So, cloud computing plays a significant role in this context, as it provides the necessary computing resources to enable the creation and maintenance of the metaverse. So, let's first understand what is cloud computing, how what are the various characteristics of cloud computing, and what kinds of models are there for the cloud computing, how it can serve better in the development of metaverse. So cloud computing is the delivery of computing resources, and these computing resources are not only physical servers, it may be storage, it may be software applications which are delivered over the internet. That means these kinds of computing resources are not placed near to you. These computing resources will be placed on remote servers. That means if you're going to access a physical servers, that may be if you're in India, that may be placed in US, that may be placed in Australia. So they are placed remotely in the data centers. Data center is a place where all cloud infrastructure is placed. So all these remotely located computing resources will be placed in these data centers, and you can access them over the internet, that too on pay as you go basis. So what we mean by pay as you go basis? Pay as you go basis means that billing will be done based on the amount of computing resources used by the consumer, right? So in this case, the keywords are like you'll be accessing the whole infrastructure or software applications or development. It may be a development platform only. So you'll be accessing this kind of infrastructure over the internet, and this kind of infrastructure you'll be getting on rental basis, subscription basis, right? So rental basis means as you live in a apartment and you pay monthly for living in that apartment. Similar is the case here. You are hiring the infrastructure. Suppose you have hired 2 or 3 servers. So based on the amount of usage of your servers, you'll be paying. Let's say there is a server which is costing $1 per hour in AWS. That is one of the renowned cloud service provider. So if you're using this kind of servers for 10 hours, you need to simply pay $10 for using that server. This is what we mean by pay as you go basis. So why cloud computing is getting a hype? What are the various benefits of using cloud computing over on-premises infrastructure? On-premise infrastructure means the infrastructure which is located in your premises, which is located in the premises of an organization. So first, a most important point is which is I have just discussed now. That is, cloud computing is based on based on pay-per-use model. That means I've just given you an example that as per the amount of usage of your computing infrastructure, you need to pay. The advantage is, another advantage is, you can scale up and scale down the resources. That means, let's say you have hosted a website on the one of the servers of the cloud, and you are getting huge traffic on your website, and you want to increase the number of servers which are going to take up that traffic. So in that case, you can increase the number of servers, and as per the increase in the number of servers, your billing will be affected. And let's say after 3 or 4 months, the website is getting lesser traffic. In that case, you can release the number of increased resources. Let's say earlier you were having 100 resources, and now you feel that 50 servers are enough to serve my website. So in that case, you can release the rest of the 50 servers. So the advantage is now, earlier you were paying for 100 servers. Like as I've told you that let's say suppose $1 is there for hiring one server for an hour, and you have 100 servers. That means you are paying $100 for 1 hour. But now, when you are going to reduce the number of servers to 50, so in this case, now you have to pay $50 per hour for hiring those 50 servers. So accordingly, your charges will be reduced. Whereas this is not the case in on-premise infrastructure, because in case of the infrastructure or the servers which we have bought for your organization in the on-premise environment, let's say the peak traffic on your website is demanding 100 servers, so you have to buy 100 servers for hosting that website. This is called as capacity planning. You need to plan the capacity, the number of servers which you are requiring for the peak traffic of your application, of your website in this case. So in this case, you'll be buying 100 servers for hosting your website so that it can serve the traffic, peak traffic, seamlessly. So when the traffic will be less, as I've told you, traffic may be more, or it may get lower when it is not getting that much load. So in that case, you'll be using only those 50 servers, and rest of the 50 servers will be idle, whereas you have spent on buying all those 100 servers, which is much more than this pay per use model, where you can increase and decrease the servers. So in this case, there is an upfront cost of buying the servers, which is equal to as per your capacity planning, right? In this case, there is no upfront cost. You just pay for the usage of your servers. Second thing is that you need to allot space for placing the physical servers in case of on-premises environment. Let's say you have bought 100 servers, so you need to allocate huge amount of space for placing these servers. Whereas this is not the case in cloud computing. No space is required because all the servers are placed in the data centers of cloud service provider. So this does not require any kind of space for placing those servers. Moreover, no experts are required for maintaining the hardware and software related to the servers, as it is all the responsibility of the cloud service provider. He is going to hire the skilled persons for maintaining the hardware and software related to the servers and related to the whole infrastructure. Whereas in case of on-premise infrastructure, you need to appoint a team, you need to hire the concerned persons for who are going to maintain the hardware and software related to the servers. That means for whole infrastructure. Then in this case, oh sorry, so that means the capital expenditure and the operational expenditure in case of cloud computing is quite low, whereas it is quite high in case of on-premise infrastructure. Moreover, if we talk about the security of the data which is going to be placed on these servers, cloud service providers are very much concerned about the data security. They are going to provide you 24 by 7 data security because they know, these service providers know that they are going to store the data of thousands of organizations, and this data is very much crucial for these organizations. So they take care of protection of data of these organizations very seriously, and they implement various techniques for securing the data of these organizations. That means they have robust plans for securing the data of these organizations. There may be, we are definitely going to implement some data security techniques for securing our data, but definitely they'll be having cloud service providers as they, this is their business, so they'll be more concerned and focused towards the data security plans. Another thing is data recovery in case of disaster. If we talk about on-premise infrastructure, we may have copied our data twice, or we may have taken some kind of backup of our data, and we'll be able to recover the data only if that backup is available. But if we think about the disaster, let's say some disaster is there, and the on premise the infrastructure which is placed in the premises is not accessible to us, or some power outage is there in the organization, then we'll not be able to get that data. So there are less chances of data recovery in those cases. But the cloud service providers have robust plans for recovering the data in case of any power outage, any other issue, or any case of disaster, because they are going to replicate the data and applications multiple times, and that too not in a single location. This their The data and applications of any customer will be replicated across multiple locations, because they are having data centers spread over a large geographical location. So they can have, let's say if we talk about AWS, it is having data centers in India, in US, and in various other countries also. So that means they are having their infrastructure distributed over a large geographical area. And if suppose US in US region, there is some kind of disaster and the customers are not able to access their applications, so they will be able to access the applications from some other data center which may be located in India or in any other country. That means data will be means cloud service provider will be having mirror solutions to deal with the downtimes, to deal with the downtimes in case of disasters. Other advantage of using cloud computing is that it provides uh, lots of massive amount of storage infrastructure. As you know, nowadays lots of data is being generated by social media websites, by IoT applications, by YouTube. So that means lots of data is being generated, that which is called as big data. So to store that data, to process that data, we need some kind of infrastructure. So cloud provides us the enormous computing and storage infrastructure to support these types of applications. So that's the another reason that it is getting the popularity and widespread adoption. So these are the key characteristics of cloud computing. First is on demand self service. On demand self service means that users can access the resources of the cloud as per their requirement and individually. They need not to have interaction with the cloud service provider all the time. Whenever they need to hire the resources, they just go to the portal of the cloud service provider, which can be opened through any web browser and which can be used using any kind of platform. Like they can use they can open the portal through mobile, through laptop, through desktop, and they can just go to that portal and they can just request the resources they require for their organization. And that's why it is called as on demand self service. Next is broad network access. Broad network access means that the computing resources which we require from the cloud, they can be accessed through internet, right? And we can use those resources from any kind of platform, that may be laptop, desktop, or mobile. Resource pooling. What we mean by resource pooling, there is a one concept called virtualization. So cloud service providers are implementing virtualization in their infrastructure. So what we mean by virtualization is that they are going to create a number of servers over a single physical server. Let's say we require, as a user, I require a server, so they'll not be allotting me the entire physical server. They are going to create multiple servers over that physical server using a software called hypervisor, and those servers will be sharing the resources of that physical server. Right, there is a physical server, we have created a number of virtual server, let's say 10 servers we have created over that physical server. So all those 10 servers are actually using the resources of physical server, they are actually sharing the resources of that physical server. But otherwise, using the technology, this hypervisor technology, it is maintained that these virtual servers are totally isolated from each other, means they cannot affect each other, they cannot breach the security of other servers, right? So in this case, as they are sharing the resources of a physical server on which they are installed, so this term is known as resource pooling. Pooling means sharing, right? So users are being allocated the virtual server whenever they require a server, whenever they require a computing resource. So we are the cloud service provider is going to allocate a virtual server to that user. So this virtual server is also called as instance or virtual machine. So that means if we are having 10 virtual machines over a single physical server, so these can be allocated to 10 different users. Another advantage is that these virtual servers may have different kinds of operating system, they may run different kinds of applications, uh, they may have different kinds of platforms. So that is what is the benefit of having this virtualization and resource pooling. Then another characteristic is rapid elasticity. This is related to scalability. That means we can increase the number of resources and we can decrease the number of resources as per our requirement. Then comes the measured service. This is related to pay as you go basis. That means uh, it will be cloud service provider will be actually monitoring the resource usage by the users. They will be controlling all this resource usage, and this will be actually displayed to you also, that how much resources you have used, and accordingly how the billing is going to be done. So this comes under measured service. That means all the resources usage will be monitored, controlled, and accordingly billing will be generated, right? Now we'll be talking about various cloud service models. What we mean by actually service models. Service models describe the type of service that the service provider is offering. So, as we have just discussed, that we may hire the servers from the cloud, or we may actually get the software application, entire software application from the cloud also. So based on this, how which type of service they are offering, we are going to categorize the this thing as service models, right? So we can have three types of service models. Broadly, three types of service models. First is software as a service. So, software as a service, under this kind of service model, cloud service provider is going to offer software applications on subscription basis. Like all of you are using Google Docs, Google Meet. So, all these software applications are being hosted on cloud, but they are providing us for free. Definitely, if you are going to get the premium version of Google Meet or any other software, you need to hire it on, or you need to get it on subscription basis, as we people have got G Suite on subscription basis, so that we can record the sessions, which as this kind of facility is not available in free version. So, software applications means, in this case, by default, you are using the hardware of cloud service provider. You are also using the platform of cloud service provider. You need not to develop any kind of application. Uh, you are just getting built-in application which is ready to use. Another example could be a software like we are using a Turnitin software. So that is a software which is used to check plagiarism of the documents, of the technical documents. So that is also we are using on subscription basis, that is hosted on the cloud, and we have taken its subscription for 3 years. That is, in this case, we are not going to install that software on our system. We are not going to maintain it. We need not. We are not responsible for upgrading it, or we are not responsible for the security aspects of this software. So in this case, the upgrades, the maintenance, the installation, everything is the responsibility of cloud service provider. Will be using this kind of software by just opening a web browser and accessing their uh, whatever website, whatever interface they are providing us for using this software. We'll be just opening that interface on the web browser, and we can use this kind of software. So this kind, in this case, cloud provider is going to manage and control the infrastructure, which includes software, servers, networking, etc., etc., and also going to manage the application platform in addition to the software application. So users are free from the burden of software installation, maintenance, and upgrading software, and all users will be using the same version of the software. Because sometimes what happens if you are using MS Word, so in that case you may be having version 10, somebody else may be having version 8, so you may have compatibility issues with each other. So in this case, that issue is not going to come, because all of the users will be using the same version of the software so that this incompatibility issue is not there. And you also need not invest in buying the hardware, right? So but there are some limitations of this software as a service model. Lack of integration support means, let's say you are having some on-premises application, and you want to integrate it with that software applications which is being hosted on the cloud. So there may be some issues in the integration because there may be lack of integration support with respect to cloud service providers. So in that case, you may not be able to integrate these applications. Another issue is that because these kinds of applications are developed considering in mind a variety of organizations, so they are not uh, specifically customized for your organization. So these kinds of applications are in standardized forms. So they will be offering you limited features, right? And also minimal customization is possible. Let's say you are thinking of customizing these kinds of applications, you want to add some kind of features in these applications, uh, for which are suitable for your organization. So in that case, minimal customization may be possible, and the whole control of these kinds of software applications are with the cloud service provider. So lack of control on behalf of you is there. So these are the renowned software as a service cloud service providers. You know, G Suite, under which you access Google Meet, Google Docs, etc., etc. Dropbox is another software as a service. Salesforce, they then Azure IoT Suite. This is provided by Microsoft. Cisco WebEx, you must have used. It is again like a Google Meet software, through which you can organize online sessions or meetings. GoToMeeting is similar to this one. Then comes the platform as a service. So it offers and manages programming platform for the developers. Like developers want to develop some application using Ruby, Python, Java, or any other programming platform. So it is going to provide you platform, so that you can just get the platform and develop your applications. So in this case, programmers or developers can create, test, run, and manage the applications using this platform. So cloud provider is responsible for managing the whole infrastructure, which includes again networking, servers, storage, etc. So that means a developer is going to see a development platform only. How the infrastructure is managed, it is not aware of that. It is not the responsibility of the developer. That is with the cloud service provider. So the developer is going to use that platform and is going to build the applications using that platform. So in this case, the advantages for the developer are that he can concentrate on the development and innovation without worrying about the maintenance of the infrastructure. He just requires the PC and an internet connection to start building applications. But one limitation may be vendor lock-in. Vendor lock-in means, let's say a developer has built an application using a platform which was provided by cloud service provider, and now he wants to migrate that application to some other cloud service provider. He wants to switch over to some other cloud service provider. So in this case, some restrictions may be there, because it may be the case that vendor has not provisioned convenient migration policies. uh, that application may need to be rebuilt on another platform and another cloud service providers platform. It may not be compatible to migrate directly. So this can be the one disadvantage of platform as a service. So AWS Elastic Beanstalk, which is a platform provided by Amazon, Microsoft Azure App Services. These are all examples of platform as a service. Heroku, Force.com. This is a kind of a customer relationship management software. Actually, Salesforce.com is a software as a service. That means they are providing this CRM software, built-in CRM software, and the same people, the same organization is also providing this Force.com, which is actually a platform given to the developers for building CRM software. So this is provided by the same organization, that is Salesforce.com. Then Google App Engine is there, which is provided by Google Cloud. OpenShift is there. So all these are examples of platform as a service. Then comes the infrastructure as a service. So cloud provider in this case is going to manage and control the infrastructure, and you'll be getting the bare infrastructure in this case. That means, let's say you want to get computing resources, storage resources, you'll be getting the virtual machines with operating system, and whatever platform you want to install, whatever application you want to develop on that platform, it is up to you. So you'll be getting actually a server only, right? Let's say you have bought servers for your organization, so in the same way you are going to get a remote server from the cloud. So it's your responsibility to how to make it secure, how to secure your applications, how to develop those applications, what kind of development platform you require. So all this, maintaining all these things will be the responsibility of user only. So this kind of service model is really beneficial for startup companies or small businesses. Let's say I'm going to start my own organizations, and I'm deficient in funding, or I'm not having that much budget to purchase a large number of servers where I can host my applications. So what I can do is I can hire the required infrastructure, the virtual machines from cloud, and just start developing my application, start hosting my website on these servers, and accordingly I need to pay for the amount of usage of these servers. So this kind of model, service model, this service model is the most flexible service models out of the three models, and the responsibility of user is maximum in this, in case of this model only. So in this case, user can dynamically choose a CPU, memory, storage configuration as per the need, instead of buying the infrastructure that might not be used for months. So as I was telling you, that the most flexible, it is the most flexible model because clients can retain complete control of their infrastructure in this service model. So AWS is actually Amazon Web Services. So EC2 is Elastic Compute Cloud. They are going to provide you. So next we come to cloud deployment models. So deployment model means that where the infrastructure of the cloud is located, and who is going to manage that infrastructure. So based on this concept, we can categorize the cloud computing into four deployment models: private cloud, community cloud, public cloud, and hybrid cloud. So let's first discuss private clouds. Let's say some organization wants utmost security. They are dealing with some mission critical applications, like they may be dealing with some software related to aircraft, or some banking software which is of very much importance, which requires lot of security, data security. So in that case, or there may be healthcare organizations where they need to comply with some kind of acts. As in US, there is a act known as HIPAA, Health Insurance Portability Act. So they cannot uh, put their data or store their data outside of their organization, or there are some norms related to storing their data. like where they can store the data. Like in case of healthcare organizations in USA, they can store their data. If they want to store their data outside the organization, they can store in the uh, storage infrastructure of some cloud, only and only if that cloud service provider is complying with that act. So AWS is one of the cloud service provider which is complying with the HIPAA Act. So in that case, these health organization can store the data on AWS also. But if there is some other organization which needs to follow some other needs to comply with some other acts, and no service provider is offering or complying with that kinds of acts, so in that case, those organizations may proceed with developing, or they may proceed with having their own private cloud, right? So in this case, the cloud infrastructure is operated solely for an organization. So in that case, the cloud infrastructure, the physical servers, as I was telling you, we can have multiple virtual servers on a physical server, and these virtual servers can be allocated to multiple organizations. So that means they are sharing a physical server. So if you want that your infrastructure, your virtual machines should not share the uh, resources with other virtual machines, the virtual machines of other organization. So in that case, you can go for this private cloud, where the infrastructure, the servers will not be shared with the other organizations, right? So it may be managed by the organization, or they can hire a third party to manage this private cloud, right? It may exist on premise or off premise. What we mean by that, let's say we want to establish this kind of cloud in our own premises. So what we can do is we can hire the we can buy the servers, the storage, as much as the resources we require for our private cloud, and we can place them in a on premises. And we can manage, if we are having manpower, to skilled manpower to manage this kind of cloud, we can manage this kind of private cloud by ourselves. But if the organization is not having skilled manpower to manage this private cloud, they can they can allow the third party to manage this cloud. Or what they can do is they can opt for private cloud off premises. Off premises means they can request the AWS, because AWS is also offering this kind of facility, where the infrastructure will be solely managed for a single organization. So in that case, they can hire the private cloud in the premises of some cloud service provider, right? So definitely this kind of cloud is having tremendous value from a security point of view, because the infrastructure is not shared with other organizations, but it is not cost efficient. It is like developing your on premises infrastructure. So that means you need to buy lots and lots of servers, you need to buy enormous storage, and then you need to hire the manpower, you need to uh, for maintaining that kind of cloud, for upgrading the infrastructure. So this cloud type of cloud is not at all cost efficient, but definitely it is going to provide you robust security. Public cloud is actually the cloud we were talking about. It is made available to the general public or industries, and is owned by an organization which is selling cloud services. So there are so many public cloud service providers: Amazon, Microsoft, Google. So all these cloud service providers are offering the public cloud, which can be hired by uh, individual users, or they can be the resources can be hired by different industries, different organizations. So this is actually representing the true cloud, which we were talking earlier. So public cloud, if we compare the private and public cloud, so it is much cost efficient in comparison to the private cloud. And another thing is that it is going you offer better scalability than the private cloud, because private cloud will be having limited infrastructure, whereas public cloud, they will be having these kinds of cloud service provider will be having huge infrastructure which may be located at different locations. So they are going to offer you better scalability and massive amount of resources also. And another thing is that they are also taking care of the security, but as we have just talked about, that if you need to, your organization need to comply with some norms which are there for related to your profession, then you should go ahead with the private cloud. Then comes the community cloud. Let's say some organizations are there which are having similar kinds of concerns. They are having similar kinds of requirements for data security. They are having similar kind of compliance considerations, policies. So what they can do is they can share the cloud, right? So this kind of cloud is known as community cloud. So that means the expenses, the operational and capital expenses can be shared by these organizations, and the cloud may be managed by a third party or by any of these organizations. Then comes the hybrid cloud. Hybrid cloud is like you want to take the services of public cloud, and already you have a small private cloud in your organization. Now you want that these two clouds uh, enable the data and application portability. That means you can transfer your data from private cloud to public cloud, from public cloud to private cloud. So you require some kind of portability, interoperability between these two clouds. So this kind of cloud is known as hybrid cloud. So this is a composition of two or more clouds that may be private, community, or public, that remain unique entities, but they are bound together by standardized or proprietary technology that enables the data and application portability. It means interoperability is being provided to you for transferring the data between the two clouds. So, where is it useful to go with the hybrid cloud? It is used by the organizations where you need to store the secured applications and data within premises. That means you can store the data which is sensitive uh, in the private cloud, and the data which is less sensitive with respect to security on the public cloud, or the data which needs to be shared with other users, that can be put on the public cloud. For example, there is some archive data that can be put on Amazon S3, which is a storage infrastructure of Amazon, and there is some operational customer data that can be put in the in-house storage, that can be put in the private cloud. So let's say, let's take an example of a grocery store chain. They want to store data related to their employees, related to the daily transactions. That can be put. That is actually operational data that can be put in the private cloud, their private cloud, or other sensitive data they can that can be put in the private cloud. And let's say they want to do some kind of analysis on the transactions which were done in the past 3 months or in the past 1 year, or they want to do some kind of behavior analysis related to their customers, that what kind of items are being bought together by the customers, or what kind of items are being bought at what time, so that they can enhance their sales. So that analysis can be done on the public cloud. So here hybrid cloud may play a significant role, right? Another example could be an organization who can use public cloud for keeping its published research, and may use private cloud for ongoing research which is not published elsewhere. So now we come to the actual concept, like how cloud is promoting the adoption of metaverse. We have just learned that cloud is going to provide you enormous infrastructure, that may be servers, storage, or networking requirements. So that is the actual requirement of metaverse, because you know that metaverse is going to support a virtual world, 3D virtual world, and it is going to generate mammoth size of workloads which require enormous infrastructure for creating this virtual space, for maintaining this virtual space, for dealing with the increasing number of users. So cloud is the solution, um, which can promote the adoption of this metaverse, as it provides high scalability that allows for accommodating an increasing number of users for the popularity of metaverse, and it eliminates the need for expensive infrastructure upgrades also, because we have just seen the difference. We have just compared the on-premise infrastructure and cloud infrastructure, that how cloud can avoid the upfront cost which is required. In case of on-premise infrastructure, you need to buy lot of infrastructure keeping in mind the peak usage of your applications. So that is eliminated if you are going to hire the resources from the cloud. So it eliminates the need for expensive infrastructure upgrades. Then next thing is increased accessibility. So it enables the users to access the metaverse from anywhere with a stable internet connection, regardless of their location and the type of device they have. You may be sitting in any part of the country, in any part of the world, you should have stable internet connection, and using that internet connection you can access the servers which are hosting the metaverse, and you can use any digital device, that may be laptop, uh, your mobile, your desktop. You can use tablets also. So you can use any type of device to access this metaverse. So cloud is going to provide this increased accessibility for metaverse. Reduced cost, we have just discussed various points, like how this cloud can reduce the capital as well as operational expenditure in comparison to on-premise infrastructure. So it is going to reduce the cost of setting up and maintaining metaverse, as users no longer need to invest in expensive hardware or software, or hiring manpower which is going to maintain this hardware and software. It is also going to provide you high availability and reliability. So what's the availability? Availability is the percentage of time the system is operational under normal circumstance. For service level agreement of 99.999% availability, the time could be as much as 5.256 minute in a year. So first of all, we should know the term SLA, which is very much popular with the cloud service providers, service level agreement. So it is a kind of a negotiation between the customer and the service provider related to the quality of service parameters being offered by the cloud service provider. Let's say he says that the application will be available all the time, or if he's saying 99.999%, these are popularly known as five nines. This term is very much popular in case of cloud service providers. So they are, if they are saying that the application will be available this much, with this much availability, 99.999%, so that means the maximum downtime for that application will be 5.256 minutes in a single year. So that means most of the time the application will be available to you. This is one aspect of availability. Other aspects could be like response time. What may be the this is one aspect of, sorry, service level agreement. Availability is one aspect of service level agreement. There may be many aspects, other aspects such as response time. How much response time will I see? Let's say I'm going to access an application, whether it will be available to me within a second, within a millisecond or so. So that response time will be stated by the service provider. Similar to that, network connectivity issues or many other parameters are there related to quality of service of the cloud. So all those will be stated by the cloud service provider. That is, let's say I'm going to provide you a maximum response time of 1 second. Within 1 second, you'll be able to access this application. If it is not so, then I'll be paying some kind of penalty or service credits to you. So everything will be mentioned in this kind of service level agreement, where uh, the metrics related to the these quality of service level parameters will be mentioned, along with the service credits they'll be offering in case the guaranteed services will not be provided to the customer. So, high availability ensures seamless experience for users, smooth experience for users. No interruption is there. You are accessing your 3D virtual world, which is being hosted by cloud, and you are getting a seamless experience. You are not getting any interruptions or any downtimes. So, that is the best thing for you, right? Then comes the data security. So, cloud service providers are also going to provide data security measures such as encryption, backup to protect user data in the metaverse. So, it is important, really important, for ensuring the safety of personal information and building trust with the users. As you know, that uh, in case of a breach of personal information security, personal information of a user, it is really going to matter a lot. So they are going to consider this issue as very much crucial, and they are going to implement various encryption techniques, strong encryption techniques, so that the data remains protected. Nobody can actually acquire the personal user data, which is really sensitive. And they are also going to take backups of your data time to time, so you no longer need to worry about the uh, data accessibility, right? Then comes the customization. So it enables developers to create customized metaverse environment that meets the specific needs of different industries or users. This can be done by hiring infrastructure as a service. Let's say you are going to hire virtual machines, and then on those virtual machines you'll be developing your metaverse environment, customized, which will be customized as per your organization needs, right? Interoperability. Then comes the interoperability. It enables metaverse environments to seamlessly integrate with existing systems and platforms, making it easier for users to access metaverse from their current devices and systems. Let's take an example of Microsoft Azure, because in that case they provide you this kind of integration. So, if you have some existing applications on your Windows machines, which are there in on premises, and you want to extend your infrastructure by hiring Windows machines from Microsoft Azure. So, it provides you that kind of facilities that you can integrate these two the applications which are there on these two kinds of virtual machines. That means they are providing you the interoperability between the public cloud, that is Azure cloud, and your own private cloud, that means the virtual machines, the infrastructure which is there in your own organizations. So if you are having existing metaverse applications in on premises environment, and you want to extend it, you want to integrate with the metaverse environments which are there in the Microsoft cloud, you can do it, because that kind of facility is being provided by many cloud service, not only Microsoft Azure, that is being provided by many cloud service providers. Then improved user experience, because you have seen so many benefits of using cloud. Definitely this is going to improve the user experience. We have seen many benefits, that is massive amount of computing resources, scalability, interoperability, customization. So that is going to enhance the user experience. That is going to uh, users can interact with these virtual environments in real time without facing any kind of lag, without facing any kind of interruption. So there are also various career opportunities in these two fields also, because integration of these two fields, metaverse and cloud, are going to give opportunities to various young people, so that they can opt their career in these domains. One of them is metaverse developer. You can grab this opportunity by learning about the designing, building, and maintaining virtual worlds and metaverse environments, and then you can pursue for this kind of career. You need to learn about all kinds of tools and platforms which you can use for designing games, virtual reality technologies, and how to integrate cloud and metaverse. Then cloud solution architect is there, where experts need to design and implement cloud computing systems and infrastructure, and you need to work with cloud providers and businesses to create scalable, secure, and cost effective cloud solutions. Similarly, we can have virtual reality designer, will be responsible for creating immersive virtual experiences, will be responsible for using tools related to VR hardware and software, etc. Then cloud security specialist to protect the data of users, uh, to ensure the security and privacy of cloud computing systems and data. These professionals are going to uh, work with the tools, and they are going to develop the techniques which can prevent and mitigate cyber attacks, data breaches, and other security threats. Then metaverse product manager, this is another career option. These managers will be helping to develop, launch, and market metaverse products and services. They'll be responsible for working with cross-functional teams of developers, designers, and marketers to bring innovative virtual experiences to the market. So this slide is showing you the various products that are being developed by various companies, and they are helping to build various layers of the metaverse. You can see cloud infrastructure is there. Here, AWS, Azure are there, Google Cloud is there, VMware are there. So they're responsible for providing computing and storage infrastructure. Other companies are also there, which are responsible for providing metaverse hardware related to metaverse, like haptics, headsets, holographics, smart glasses. Even Microsoft is also providing HoloLens software. Then virtualization tools you can see. And for developing virtual worlds, these companies are developing the hardware and software. Then for e-commerce in economic infrastructure, Visa, PayPal, and these various companies are coming up. Then AR/VR games are being developed by various companies, and so on. So specifically now I'll be focusing on the infrastructure which is provided by Microsoft Azure for Metaverse. So it's a public cloud which is being offered by Microsoft. So they provide a broad range of cloud services, including compute, storage, and networking. Why I'm talking about these cloud services? Because these are the core of any cloud solution. Compute services, storage services, and networking services. Again, it's based on pay per use model or pay as you go model. So basic building blocks of Azure infrastructure are data centers, which actually house the infrastructure of the data center. Is basically a term used where the infrastructure of cloud is housed, right? So again, the Azure infrastructure house their computing, storage, and the networking services in the data centers, which are distributed all over the world, and they contain physical servers arranged in various racks with dedicated power, cooling, and networking facilities. So data centers are further grouped into Azure regions or availability zones, and they are having more than 60 regions in 140 countries. So this is showing you one Azure region which is having further three availability zones. Azure region is actually, you can say, a location where multiple data centers are there. So this is showing you one Azure region which is having multiple availability zones, and each availability zones will be having one or more data centers. So that means they have divided their infrastructure uh, at first level into regions, and then regions are further divided into availability zones, and each availability zone is further having many data centers, right? And these data centers will be having their independent power, cooling, and networking facilities. Why they are having their independent uh, power, cooling, and networking facilities? Because if one data center or one availability zone is having power issues, or any is affected by any kind of disaster, so it does not affect other availability zones, so that users can access their data and applications from other availability zones, right? So they have given a term Azure geography to an area of the world that contains at least one Azure region. So, for example, India is a geography because it is having two or three regions, right? So, we can say that India is a geography. Then a term region pair is there. Region pair means it is actually a pair of regions within the same geography, and these regions which are in pair, they will be separated by at least 300 miles, right? So, why these region pairs are there? Again, they are there to provide you data recovery in case of disasters. Because if one region is not available to you, you can access your data from other regions, because they are going to replicate the data and applications among these region pairs. Like here, if I talk about a region pair in India, so you can see there is a region pair of Central India and South India, right? So that means data will be replicated between these two regions, and if you're not able to access your data from Central India, automatically you'll be given access of your data and applications from South India data center. So you can get the details from this link. So, regions in a geography are paired to ensure business continuity and disaster recovery. And if there are any planned updates by the Azure, they are also rolled out to paired regions sequentially. That means if they want to update the infrastructure or software, they'll be updating uh, it in one region, and then when that those updates are completed, only then they'll move out to second region. So this kind of concept, which is known as rolling update, it minimizes the downtime for the users, reduces the bugs and logical failures in the rare event of a bad update. Such as, suppose the update was not successful, it affected that hardware or software, and that is not available for a particular time period. Then in that case, that update will not be done in the second region, and you will get the accessibility of your data and applications from the second region. That's why this concept of rolling updates is there in case of Azure. So Microsoft started its data center journey in India in 2015, and currently it is having three data centers in three regions. It is having data centers in three regions. So one region is in central India, that is in Pune. Second region is named as South Indian region, which is in Chennai. Third is in West India. This is called as West India region, that is in Mumbai. And they are also planning a data center in Hyderabad, which is expected to be operational soon. So let me show you the global infrastructure of Microsoft Azure, because I just want to give you a picture like how they are maintaining their infrastructure. I hope it's visible to you. Is my screen, this website is visible to all? Please acknowledge.
Yes, ma'am, it's visible.
Visible, ma'am.
Okay, just a minute. Yeah, you can see various data
Sorry to
centers
interrupt
of.
you, ma'am. Is there any audio in this, or it's like this
No, no, no.
animation?
There's no
Okay.
audio. It's
Okay,
just
ma'am. Please continue.
their website, right? So these blue dots are actually showing you. Let me show you. Yeah, yeah. These aqua color dots are showing you the data centers which are located all over the world. They belong to Microsoft Azure. So this is showing you the China East 2 data center. Yeah, this is Southeast Asia, Singapore data center, and yeah, this is South India data center that belongs to Chennai. Let me show you. Yeah, let me take you to a virtual tour of Microsoft data center so that we can see actually how the data centers are managed. So it is, yeah, we are going to enter into the lobby of the Microsoft Azure. Just going to give you a virtual tour, right? So if you want to explore the lobby, you can just click here and you can see, just move out, just drag your mouse and you can see what kind of facilities are there. Like this is showing you that some kind of biometrics is there for the employees who wants to enter into the operation room. So if you click here, it will show you that some kind of security check is there. uh, you can read multi-factor biometric authentication control access to data centers. So they have to undergo the security check first, and only then they can enter the operation room of the cloud. So let's enter into the operation room then. Yeah. So you can see that all the statistics related to infrastructure are being displayed here so that these people, these employees can monitor, and if there is any issue they can tackle that issue, right? You can drag and see, right? Then we'll be entering into the mechanical area. We'll be entering into the server room. So now you can see that these are actually the racks which I was talking about now. These are the racks, and in these racks you can see these are the various physical servers which have been placed. These are the servers placed in the racks, and these racks are again independent in power and cooling facilities. So so that if there is an issue with one rack, it will not affect the other rack, and we can access the physical servers from these racks, right? So this is the how the infrastructure is managed in case of cloud. You can see how the networking is done, right? Next we'll be going to the networking room, where networking facilities will be managed. See how networking is done, how networking is managed, so that all servers are connected with each other, and you can also remotely access the infrastructure of the data center, right? I hope you have got an overview of Microsoft data centers. Let's go to the PPT. So if we talk about compute services of the Microsoft Azure, then they virtual machines are going to provide you the compute infrastructure. That means whatever applications you want to run, or you want to host a website. So first of all, you need to hire a virtual machine, and then you are going to put or develop your applications on those virtual machines, and then they will be executed. So you can hire Linux or Windows virtual machines. So there are many options related to this these virtual machines. That means many platforms are being supported, many operating systems are you are having options, various options for platforms, operating systems, and various other things. As per your requirements, you can hire the virtual machines. So Azure virtual machines provide organizations with a secure and reliable way to host their applications and services, and you can easily increase the number of virtual machines and release them if as per your changing demands. So this is a facility through which you can automatically increase the number of virtual machines. You just have to mention that when my CPU utilization is above, let's say 75%, then just add the number of as you can add the number of instances by one. You can see, right? This kind of interface is provided to the user for automatic for auto scaling purpose. So if you mention here that CPU threshold is 75, duration in minutes is 10, and number of instances to increase by is 1. So that means whenever CPU utilization is increases above 75%, that it remains there for 10 minutes, then the number of virtual machines will be increased by 1. Similarly, if you want to release the resources, you can specify that if CPU threshold is 25%, then just decrease the number of instances by 1. And this is the policy which is there for removing the virtual machines. Arbitrarily, it will not be removed. Let's say default is you can remove the virtual machine with highest instance ID, means with highest VM number, right? You can choose other policies also as per your requirements. So availability sets are there. I've shown you that various racks are there. So you can, if you are replicating your data and applications in virtual machines, various virtual machines, so you can have virtual machines in various racks. So that if one rack is not working, you can access your virtual machine from other racks. So these are known as virtual machine availability sets, right? Similarly, we are having Azure storage services. So basically, they have categorized them in five ways: blobs, files, queues, tables, and disks. Blobs actually refer to binary objects like text and images, etc. And tables are NoSQL tables. This refers to managed disk, which actually going to store uh, the huge storage objects. Then these storage objects can be accessed from anywhere in the world using HTTP or HTTPS protocols. So this slide is showing you various replication strategies of Azure. Uh, One is locally redundant storage. So it copies your data synchronously 3 times within a single physical location in the primary region. That means if let's say you are in a central India region, right? So your data will be replicated across three different virtual machines, but that will be in the same primary region. So it is the cheapest alternative, because in this case, if that region infrastructure of that region is not accessible, so you'll not be able to access your data from any other region, right? So this is complemented by zone redundant storage. So it copies your data synchronously across three Azure availability zones in the primary region. In case of LRS, the copies were built in the same availability zone, whereas in case of ZRS, the copies are made in three different availability zones but in the same region. So, in this case, if this availability zone is not working, we cannot access our data from this availability zone. It will be accessible from second availability zone, right? But if the whole region is affected, then we'll not be able to access our data. So there are other replication strategies also where data will be replicated across regions, but these options are costlier than these two options. So if we talk about networking services, as in case of Metaverse, we require high-speed networking and connectivity. So Express Route is one service of Microsoft Azure that enables you to create private connections between Azure data centers and the infrastructure that is in your premises or in a co-location environment. Similarly, they are also providing CDN, Azure Content Delivery Network, that is a globally distributed network of servers that can efficiently deliver web content to consumers. Basically, it's a facility through which you can store the content on the edge servers, cached contents on the edge servers. Edge servers are nothing but a uh, um, this is a kind of infrastructure which is located near to your organization, and they are known as edge servers that are close to users, thereby minimizing the network latency. So it also offers a range of services that optimize network performance, including Traffic Manager, which allows for load balancing and traffic routing. So specifically, if we talk about Metaverse offerings by Microsoft, so these are mesh for Microsoft Teams. In the recent past, they have developed this mesh for Microsoft Teams. What the users need to do for using this kind of software, they need to join a standard team meeting. You know about Microsoft Team. It is again like a Google Meet software where multiple users can join and they can have online meeting or like a conference call type of thing. So in this case also, the users need to join a Microsoft Team meeting. But in this case, if we are adding this mesh to the Microsoft Team, they can add their customized avatar instead of a static picture or video. And organizations can build immersive spaces within teams. So these avatars can use these spaces to mix and mingle, collaborate on projects. So I'll just show you this kind of view is there. They are provided by Microsoft again. Here you can see that team members have built their avatars, right? They have built their avatars, and organizations have developed an immersive environment, metaverse environment, so that they can collaborate with each other like they were collaborating in the physical world, right? So as at the time of corona, this kind of environment, this kind of software was built so that they do not feel like that they are working from their home, they are isolated from each other, so that they can get a feeling of working together in the organization. That's why this kind of thing was built up, and they are giving them uh, immersive space. So this was related to a product design team within Microsoft. They actually created an immersive space for their daily stand-up meeting. On one virtual wall, you can see that we can have customer pictures to keep the team grounded. A whiteboard is there on another wall, which displays the color-coded tasks, and the product prototypes could be displayed on the table. So this kind of virtual environment can be set up where employees can collaborate with each other like they were doing in the physical world, right? So this is going to increase their productivity, and sharing, they can share with each other as they were doing in the physical world, right? So, digital twins is another technology which is being offered by Microsoft Azure in the area of Metaverse. This can be used to create complete digital models of entire environments. So, it is a kind of a IoT platform that enables the users to create a digital representation of real world things. That may be, let's say, if you are creating a real world representation of an industry, where lots of machines are there, they are working in sequence to build some kind of product. So we can have real world representation, digital representation of every machine in this platform. So it is like a digital twin of real world thing. So to keep these digital twin properties current against your environment, you can connect your solution to IoT devices. So what we can do is, if we want to uh, imitate these devices, these machines, real time in for the digital twins, what we can do is we can get the status of these virtual machines by putting we can get the status of these machines by putting sensors on these machines, and the real status of these machines will be communicated to these digital twins, and they will behave similar to the actual machine. You the current status of the machines in the industry. So further, the data in your this digital twins models can be routed to other Azure services for more analytics or storage. Basically, this these kinds of digital twins are prepared to for predictive maintenance, that we can predict in advance if some fault is going to be there in these machines in near future. If it is so, then we can rectify those issues in advance, right? So one application of this is predictive maintenance. We'll be analyzing the data we are capturing from these machines through IoT, and then we'll be analyzing this data to get predictive maintenance, or other applications may be there, right? So it allows you to gain insights that help you drive better products, optimize operation and cost, and create innovative customer experiences. So Microsoft technology, using Microsoft technology stack for metaverse application. This is a brewery industry, a famous brewery industry. They have used this technology stack, and they have really improved shown an improvement. They have really optimized their operations and cost, right? If time permits, I can show you, this is small video. It's not showing here.
You can send paste the link in the chat box even.
Yeah, I'm doing that only.
Ma'am, the it will not be audible. The video will not be audible. Can I share it as a tab, ma'am? If you can just paste the link in the chat box.
Is it audible?
No, no, ma'am, it's not audible since you have shared the entire screen. Can you just
Okay.
give the link to me in the chat box? I'll
Sure.
share it as a
Sure.
tab, ma'am.
Sure.
Ma'am, also I would request you to stop sharing after sharing the link.
Okay. Okay. So as you have seen that they have actually built digital twin for their beauty industry to find to deal with the predictive maintenance, as well as you can see to find issues in packaging, for can line optimization. So that's how they are optimizing their operations. Let me share my screen again. So next we come to futuristic trends in metaverse and cloud. So what can be the futuristic trends? Purpose built or specialized cloud for the metaverse. As we know that the metaverse actually requires the virtual machines which are having huge computation power. Basically, this technology requires GPU kind of virtual machines, or maybe more high end virtual machines. So what they can do, these cloud providers can do, they can develop environments which are dedicated especially to the metaverse. Means only those kinds of virtual machines, that kind of storage infrastructure and networking facilities will be there, which are totally focusing on metaverse environment, because this kind of technology is highly relevant as enormous size of workloads needs to be migrated to the cloud so many times a day. And generic cloud services, that means low end virtual machines, they may not be able to cater to the huge computing and storage requirements. So big cloud providers, they can focus on building specialized cloud for the metaverse, and the small service providers, they can keep on continuing serving the needs of other industries. Hybrid clouds are really popular to deal with the bandwidth issues, internet outages, data breaches, loss of personal information. So, if you want to keep your personal data secure on private servers, then that data could be kept on private cloud so that it is not exposed to the public cloud, and that will give super protection to the data. Also, one advantage is that it will decrease the latency, right? Latency is the time taken to transfer the data from server to the application. So if we want to deal with these bandwidth issues and internet outages, what we can do is we can keep some data on the private cloud, and the data which needs huge computation power or analytics, that can go to the public cloud, right? That needs more scalability, that can go to the public cloud. Even in case of public cloud, they are providing you edge computing. Means some of the infrastructure is maintained near to the users, so that this is especially useful for like I was telling you about Azure CDN. This is a kind of edge computing network where the servers are located near to the users to optimize the latency issues. So what we can do is, if we want to minimize these bandwidth issues, some of the data can be placed on these CDN networks, and the data which requires scalability, etc., that can be put on the public cloud. So, metaverse as a service, this is a new term which is coming up. Like I told you that majorly there are three kinds of service models: software as a service, platform as a service, and infrastructure as a service. But specifically, if service provider is, let's say, only providing database services, then they can term it as database as a service, because they have developed their infrastructure for serving these kinds of applications. Similarly, storage as a service, database as a service, many kinds of as a service terms are coming up. So this is another as a service terminology which can come up. So cloud providers focusing on the metaverse will build metaverse compatible solution, not only in terms of infrastructure. They can have platforms, they can have software applications which are focusing on providing metaverse as a service to help companies establish their virtual space at lightning speed. That means they can quickly develop their metaverse solutions using these types of service solutions. So that's all from my side. If you have any queries, you can just